What is this meeting and this course about? For you particularly, this course is called DatZ2186-N for English, and it is held in autumn 2022. And what is this course about? From academic perspective, you will earn 4 credit points if you will finish this course successfully. Something is still not right about amounts. I think proper number should be these ones, but of course we can double check that as well. So 4 credit points in total, 2 for theoretical part, 2 for practical part, and everything will be held remotely. All theoretical and practical sessions either through Zoom or through different communication tool. Half of this time will be spent for lectures and theory, another half for practical work, and then, more than that, it is expected that you will work in teams for your practical exercise, and more details about this probably I will tell you next week. So these meetings will be happening all the time at the same time on Mondays, let's say evening, not night, from 6 p.m. to 9 p.m. If we will finish earlier, then we will be happy about this. Hopefully we will not do it longer. Somewhere in the middle during this time we will have breaks, at least 15 minutes. If there will be requests, maybe more. And then in these Monday evenings, some part of these regular meetings will be also spent to discuss things about practical exercises. Preliminary plan is to do it each second week, starting from next week, next Monday, and maybe not the whole time from 6 to 9 p.m., but second part of the time, something like 7:30 till 9. And if you are curious, you can also read 2 very heavy books about this course and information on what this course is based. One heavier book is Jan Sommerweil Software Engineering, 9th edition, and one less heavy book, don't remember this press one, Software Engineering, a Practitioner Approach, 7th edition. And the web page of this course is this link. I can try to open it and copy it in your chat as well. But this is preliminary place, because if you look on history of this course, originally this course was done only in Latvian and was called DatZ2186. Then English version was introduced for Reagan bachelors and other students who are studying in English. And then particularly for your group, another course was introduced, which is a little bit shorter. So if you look on parent page of this Moodle system, this course is for 6 credit points, so a little bit heavier, mostly because of more content provided for theoretical part. And particularly for your group, it was decided that you can get enough knowledge with a little bit shorter course, and your course is based on this by sacrificing some of not so important parts of that course. Unfortunately, I'm not doing organization for this. I'm working only as a lecturer, teacher, but as far as I was told, all of these students, bachelors and these college students, were counted together and registered in the same parent course, this one, and this means that through the system perspective there is no difference between you and other students studying for this little bit heavier course. And so everybody were put together and no separate solid course is created yet in Moodle system at the beginning. And as we will not have separate page for this course, all the content I will have, which will not be much, that will be records of presentations and later, of course, different kind of work information related to your practical exercises will be put in this place, in this single page called Course Schedule Autumn 22. Actually, it will not be only course schedule, it will be course. Any questions or comments so far? So is it all here? Okay, if you want to go in details, to successfully finish this course, you need to do two things. You need to pass knowledge checks for theoretical knowledge, and there will be two knowledge checks made as a multiple choice tests. This probably less user-friendly application as you used to use, and also you have to participate and get possible results for this practical exercise. And for practical exercise you will need to write only documentation of some sandbox imagined project, and to get this course passed, of course, result should be at least what would it call? Sekmīga atzīme. Accepted rating inside your team as a contributor and as a result of the team. And so just to get this course passed, you still will need to participate at least for theoretical checks of your theoretical knowledge, and at least to participate and to not drop out of your teamwork, and then you can get some lowest possible accepted rating to finish this course. And of course, if you will do better, then you will get better score till to 10 if you get exceptionally good results. And so that's about these things. And if we look on schedule, yeah, go ahead. So, and if you look on plan of the course, so here in total we will have 16 meetings. I don't know is exam time included in that or not. So either 15 plus exam or 16 plus exam if an exam will not be mandatory. That's the usual approach how I conduct courses. I try to allow for students to get good enough score just by doing all required activities. So, and these activities which will be rated are 2 tests for knowledge checks for this part of theory, And here for review, you will not get actual ratings, but we will have 4 reviews for your practical exercises. But the final rating will be just about your deliveries, what kind of document you will deliver at the end of your teamwork. And these reviews will be just to check that you have progress, that you are going forward, and that you do not leave everything for the last moment, because if you leave everything for the last moment, usually results are quite poor. I do not recommend to use closed source tools, and I myself use LibreOffice, not Microsoft Office, but in general your deliveries for knowledge checks will be submitted data through the web interface, so any browser which you like can be usable, and for delivery accepted format is PDF, and how exactly you generate it, what exactly tools you are using, it is up to you. We will talk a little bit about practical approaches, what could be recommended approach for your teamwork when we will talk about practical exercises, but in general you will not need to have any specific things. And if we go to contacts, so my name is DatZ2186 and I Latinize my surname just by dropping out all diacritic marks from these Latvian letters. So in English it becomes DatZ2186. Currently I'm senior software engineer at Netcracker. Quite long time before that I worked as a freelancer in my own company, Sia Odo. And for public interface I still use these contacts coming from my website or my company's website. So my CV you can look at odo.lv/valdis_vitulins_CV, and my email address is valdis.vitulins@odo.lv. And for practical exercises you will have another teacher, because group is quite large, and if I'm single teacher, we have to spend, and I have to spend quite a lot of time just by reviewing your progress and discussing your problems. So for practical exercises, when we will need to discuss some common things, everybody will join to the same meeting. When we will discuss particular issues for particular teams, we will split in 2 parts. So one part will be conducted by me, and another part will be conducted by teacher Jānis Iljins. He is systems analyst at DatZ, and here is his LinkedIn contacts, and his email is janis.iljins@di.lv. So that's about contacts. And if we look here in theory and practice, so in general, if we look how software development is related to more fundamental sciences like mathematics, and probably you know that original Englishman and American things that math should be with S at the end. My contribution as a foreign user of English is to regularize English as much as possible, and I think that the proper noun for math is just math, not maths. So, coming from mathematics, then you can study different kind of algorithms, and if you are heavy interested in algorithms, then probably the best heavy book is written by Donald Knuth, called Computer Algorithms, I think. And then you go to programming, and so we go more and more to practical approaches and to management, and less about mathematics, algorithms and tools. And this course will be about, not even about programming, because that you will learn in other courses, but mostly it will be about, you can say that it's only about management, but if we look in more details and in more proper meaning, software engineering is not management. Management is something more general, even more far away from algorithms, programming and source code, and it is probably wider and bigger than management. So in this course we will talk mostly about software engineering as a different kind of practical and theoretical approaches and some theories based on these practical approaches and observations, how to develop software faster, cheaper, better quality, etc. And then we will also talk a little bit about project management, not in very many details, that everybody of you will be ready to manage projects, but at least so far that you will understand different kind of roles and people involved and approaches, etc. I record it already, but I'm not using Zoom. And so all these things which are more practical are also related to different kind of technologies and tools, but this course will be quite theoretical, and you will use tools based on your choice, which you will find out pretty primitive or simple, because in general you can pass this course just by knowledge of Office applications. Of course, everything more than knowing Office applications will help you, but in general, so this will be about things around programming, things around writing code, testing code, etc., without writing and testing code itself. And if you look in more details, so here are some most important topics mentioned. First, I will tell you about a life cycle of software engineering. Of course, I will tell you at least what is considered software and what is considered software engineering. Then different things which you should know about system development and how to start, develop systems, how to design, how to collect requirements for them, how to model them, etc. Then one part of important topic is quality assurance and testing, how to be sure that developed software conforms to requirements. And then about systems maintenance, how you maintain system, how you still develop already used system, how you deal with different kind of issues coming from complexity of systems, which is called configuration management, and then also about project management, estimation techniques for projects, and if we will have enough time, that was one part of topic for this heavier course, Office Ergonomics. If we will not have time for that, then if you're curious, you will look for this more heavier course and its materials. And in practice, you will need to choose groups by yourself. Requirements for groups are, what are official requirements? Official requirements are 3 or 5 people in group. My recommendation is to have 5, because 5 is big enough to get a feeling of working in a group, because some of you already may have experience developing software, working on software as a solo player or in very small groups, and 5 people is big enough to see how teamwork works, and small enough that you can still manage it if you are not experienced enough. But if they say that the official requirement is at least 3, so probably we'll accept. I would not be happy with such small group, but you should start with 5 people in a group. And then you will need to develop everything for for hypothetical system, which you may implement later in different course. You will have some more heavier course about programming, etc. And so you may try to reuse already designed documentation for this software, but you will finish this particular course just by designing requirements, design, plan, and general concept of this system before actually writing any part of code. So, any questions or comments so far? If no, then we can go forward. And probably you already have feeling and know it, but we should start with definition still. So first, what is software? And software is 3 parts. First, instructions for computer what to do. And that's what is usually de facto standard for inexperienced developers to think what software is. But also software consists of data structures, what is needed to actually do this required work. Because for any non-trivial software, you need to store some data in some structured way, either in relational databases or in XML files or YAML files or different kind of no-relational systems like MongoDB, Cassandra, whatever. And also, any non-trivial software should have descriptive information about this software and data structures, how it works, what it holds inside it, what it stores there, and how it everything fits together. So that would be documentation. So actual code which does something on computer, data which are needed and may be created by this software during its running to store some useful information, and then some kind of documentation in different forms which actually describes what this software does, what its data structures represent. And so these 2 other parts may be missed by inexperienced students, because usually students start with quite primitive and simple programs which do not remember much of things, which can be self-learned just by try and error method, etc. But when you go in larger and more complicated systems, then of course these 2 other parts are very important. And for software engineering is some kind of disciplined and organized approach to get better software with least amount of effort. What is better software we will talk in more details later, but idea here is that there are some good approaches how can you get better software, and there are some worse approaches how you can spend quite a lot of time by getting nothing. And so software engineering is this emerged practical approach and some theoretical models built on top of these practical observations and approaches to understand what is actually going on when software is developed and maintained, etc. And so software engineering is large and complicated subject. Important parts of it is how you develop software, how you check that it is good for your particular needs or for needs of your customer, and then how you can evolve this software while it's still used in production, and how to make changes in moving target, what is this running unused software. And difference between software engineering and computer science is that software engineering is a very practical approach. There are some theories behind these models and approaches, but nobody says that these are actual good theories. These are just observations and some models built on top of observations, and this means if you will observe something else, you may come up with different theories and different models how you can describe these things. And so software engineering or system engineering varies difference because in large complicated system sometimes software is not most important part of the system. And then you may talk not only about software but about systems engineering. And when you talk about systems engineering, think about cars, think about Mars rover, think about artificial satellites, think about large factories, etc. All of these things are actually hardware, but many of these things of hardware are managed by software, so you actually need to develop both hardware and software, and when both are very heavily influenced by each of other, then you talk about systems, which means, in most of cases, it means software together with something else, either hardware or data or whatever. And then a problem with software is that for any kind of theoretical course like this, there are no good approaches which fits for any kind of project and any kind of developed software. And because software becomes more and more widely used everywhere, so almost any device which uses electricity probably has some chip inside it, and this chip runs some kind of software in it. So it means software is almost everywhere, and these devices with chips inside them are very different, and because of that software is very different. And if you look on small scale systems, we can talk about embedded software, which is specific set of software with embedded in small devices like elevators, clocks, microcontrollers, etc. Then we can talk about system software, which manages very large systems. Then we can talk about application software, and my understanding what application is software which is used by human user. So if we use something as a human, as a person, we use applications. Why these are called in such a way, I don't know, but or apps in jargon, in short. But these are again different subset and kind of software, because the most important part for this is user interface, how exactly user can use this software in the most efficient way. Then there are again very different subset about engineering and scientific problems, how to solve different kind of equations, how to do different kind of simulations for buildings and fluid dynamics and weather forecast, etc. Then there may be different kind of software to produce something in automated factories, product line software, which actually overlaps with embedded software. Then, particularly for applications, there are specific set of software called web applications, which you do not install but open in web browser, mobile applications, which you may install on your mobile phone, cloud computing, which is software running on somebody else's computer, provided by Amazon, Google or Microsoft or whatever. Artificial intelligence software, which is actually machine learning software, etc. So that means that because of these very large differences, there are some good approaches for some particular set of software, which may not be so good approaches for developing different kind of software. But in such course, of course, we try to tell quite general truth about things which may be applicable to most of such kind of software. And software is developed or engineered, so developing in these terms is a little bit more narrow terms than engineering, because mostly developing means writing code, debugging it, maybe testing, maybe not, if you consider testing as a different aspect. But engineering is all other things, how you package it, how you deliver it, how you deploy it on production, etc., etc. And because software in general is ideas written in machine executable form with interpretation or compilation or whatever, in general this means that software in theory should not wear out. So in difference with hardware, you cannot make worse just by using it. And that's the difference from hardware, because hardware is physical thing. Physical things are moving around with friction, which were so different kind of parts. And if you look on defect rate on hardware, you see many defects, maybe not so much as here, but you catch up defects in very early stages during manufacturing or development of software and immediately after that, because these are defects which somehow skipped quality control or were found during quality control because of faulty manufacturing process. But then when you catch all these and patch all these problems, then usually you can use hardware for quite a lot of time without any issues, because everything is fixed, everything works properly. But then when it becomes older and some parts wear out faster than other, you see that different kind of age problems comes into hardware. So you need to replace more and more things, still to things that you need to replace everything. Of course, in theory, there may be some hardware which you replace and it continues to live forever. Maybe you have heard this folk saying about Nordic folk saying about Thor's not hammer, Thor's axe, Thor's axe, that it was used forever. Only thing was that sometimes actual axe was needed to be replaced, and sometimes it's cuts. So sometimes you replaced its metal part, sometimes you replaced its wood part, but axes together was used forever. So you may continually replace everything and then you go back, but if you don't do such replacements, so problem with hardware is that it wears out. In theory, if you find out during manufacturing quality process in early stages of usage and you fix different kind of problems in software, in practice they should go till to infinitely small amount because everything you find you can fix and then it works forever. But this is in ideal world where nothing else is changing. In practice, when you run software, it always lives and runs inside some other software, inside some hardware, etc. So there are dependencies upon dependencies. How this particular software developed and used by you is influenced badly or goodly by other things. And what is actually happening is that first, if you do some updates of your software or some external systems, suddenly many more defects may come up. And of course, you may try, and you usually do, fix them, and then it exponentially decays and becomes smaller, but then some other changes comes up into your software or other software, etc. Then you try to fix them, and then this lower trend of different actual defects creeping into software actually gradually comes up. It doesn't go down as in theory, in ideal practice, if everything what depends on would be only your software, because more and more changes are collecting here, which makes your particular software which you are maintaining and building more and more irrelevant, more and more obsolete. And so, similarly as to hardware, if you do not do some complete replacement with one software with another, sooner or later it becomes so irrelevant that it actually doesn't work, so it is completely broken. And if you will work particularly in quality assurance, you will see that also because of that, number of unclosed defects gradually creeps up. Because of different issues, if you do not fix it early, then it becomes harder and harder to fix until you need to do some policy approach like closing all defects which are older than few years or whatever, because otherwise all these things about irrelevancy, about technological depth, etc. Slumps together. And so what is software engineering? Software engineering is quite a wide area. We can look and we will look on it from different aspects. And problem with software engineering is if you are specialist and you go in one particular area, you may focus your attention only on one particular thing, and then you have this issue like 7 or whatever blind men touching elephant, and if they touch different things of elephant, they may decide by touching, and that means covering some aspects of elephant, that it is something completely different. And hopefully when we will look on this course on software engineering, we will touch all important parts about software engineering, that you will not have just one single point of view what it is. And what are most challenges for software engineering? Most challenge is that software becomes more and more complicated, and these times when you wrote software very narrowly focused for some particular things which you actually can describe as a mathematical algorithm are quite long gone forever. There are still projects which of course tend to use algebra and mathematics quite heavily, but this is just one subset of software in general. And also software development is quite expensive, even though in general software is just ideas converted into machine executable form, and ideas in general do not cost anything to replicate, to spread, etc. And then there are different kind of software which are very different and different things. And probably you may have already, but one of important thing is to debunk different kind of myths regarding to software development and software engineering in general. And here these are categorized as 3 different kinds, one coming from customer or from user. I will tell you later. So customer and user is not always the same, because customer, in my understanding, is organization or person who pays you money for software engineering, maintenance, development, testing, whatever. But user is who uses this system. There may be systems which are not used by user as a person, which are used by other software. So users may be just a different kind of software. For example, if you write different kind of libraries, your libraries will be used by other software. This software may be, of course, written by other persons, so you may say that your users are different developers. But important thing is that the customer and user in many cases is not the same thing. So customer here is person or organization who pays you money for your services. Then different kind of management myths, which comes from team leads, project managers, organization managers, etc. And then there are some kind of practitioners myths, which are about developers, maybe testers, maybe also some managers who are working in software engineering and who also misunderstands some of important things about software engineering. And first, most important thing coming from customer myth is that some may say, as a person or organization, I have $1 million idea, you just need to implement it. Very widespread, I think this is one of the most widely seen misconception about software. And my answer in short to this is that there is no $1 million ideas. There are only $1 million executions and implementations of these ideas. And if you will look more carefully, for example, about biographies about legendary persons who may claim that they had $1 million ideas, they actually become popular and successful not because they had such ideas, but because they probably, these other persons, probably abusing these other persons, implemented and executed these ideas in such a way that they become popular. I think one of the most prominent guys here is Steve Jobs. He is not a person with $1 million ideas. He was not a person with $1 million ideas, but he was a person who could execute his ideas in such way that this execution earned millions. And so that's the most important thing. Ideas in vacuum do not cost anything. Only ideas which you can somehow implement and ship into real product, these counts, and then you will see that probably initial idea was actually wrong, but when you started to implement and execute it, your idea changed to something else, and then you usually forget about this. This is winner bias, that usually what happens is that if you are lucky, you think that it was your achievement. Yeah, so about biases, if you are successful, you think that it was almost entirely your achievement, but if you get unsuccessfully, it's almost always external factors and something else. But what actually happens is that if you got lucky, maybe it's because of external environments, etc., you just got lucky. And if you got unlucky, you got unlucky just because you got unlucky. Of course, with some proper approaches how to do these things, you may improve chances of your luck. But you always need to remember that you should consider your success and failures in more or less equal weight ratio. So if you say that your success was 100% yours, then your failures also should be 100% yours. And if you think that your failures was just something else, then probably your luck was also something else. So that's about one very widely spreading misconception. Other thing is more concrete. For example, that if you just describe your $1 million idea or whatever idea in general statement of objectives, what it should do, etc., then all these details may be filled later. In practice, it shows that as more vague and ambiguous initial statements about problem and possible solution are, as bigger is rate of failures, because details matter. Details matter everywhere, and in software engineering as well. And here is another problem, that when you go into more and more details, then the details may change a lot. And because software is much more flexible, we will talk about re-engineering and refactoring, that you can rebuild software much cheaper than hardware, than buildings and ships and cars and whatever. So changing requirements is much cheaper, but changing requirements is much cheaper in software than in hardware, but changing requirements still improves possibility of failures in side project, and therefore you should be as much concrete and specific as early as possible, and otherwise, again, percentage of failures may increase. So from management perspective, I think most important myth is that you can just throw more persons at solving problem and it will be solved quicker, faster. And this is something like, forbid my sexist joke, throwing more women at carrying out more babies during, I do not know, 3 months or whatever. So if you can get baby in 9 months approximately, then throwing more women at the task, or men, will not improve your time at all. You may get better results on average during larger time, but definitely it will not make things faster initially. And it's similarly for software. We will talk what are reasons for that. But one of the reasons is that software development and engineering in general is very labor intensive and knowledge intensive, and you can not add any person in the project like you can add, I do not know, more persons doing very basic tasks like digging holes in the ground or whatever. So if your goal is just to get more holes, dig it in the ground without any order, etc., then probably more persons digging it will get bigger number of holes. If you still need to get bigger just one single hole, then there again are physical limits how many persons you can put into this hole to do it in parallel and faster. And similar it's for software. So you can catch up only if you can do serious parallelization, if you can do many things at once in the same time, which are different and which somehow complement each other. But you will see that many of these things are quite hard to parallelize. And other important misconception is coming from Eric Steven Raymond in his book named Cathedral and Bazaar, that software is largely a service industry operating under the persistent but unfounded delusion that it is a manufacturing industry. So it was much more closer to truth 10 years ago, 15 years ago, when almost everybody used so-called commercial off-the-shelf products, which means companies like Oracle, Microsoft, IBM write software, puts them into shelf, into CD or tape or whatever, then customers come, pays for these artifacts, these shipping items, and put these CDs in their computer, install and use them, etc. So idea for this commercial off-the-shelf products is that there are party which just develops new things, like they are building cars and building and whatever, and then there are customers which just take these from the shelf and use. But software is much more dependent on services and maintenance, and now when you use open source software, which you can legally use for free without paying any money, you see that this approach, commercial off-the-shelf product, is absolutely wrong. Because actually you can get software and you can use it for free. But what actually pays for company is development, services, bug fixes, etc., etc. So if companies work in closed source approach model, and we will talk in more details about this later, that they think that their delivery is this closed source application and nobody else needs to know how exactly it works, what kind of ideas were put there, they have quite a lot of problems. Reverse engineering is just one of many of their problems to get their business model working. But fortunately, this approach is not so popular as it was 10 years or 15 years ago. Still, open source software is not so popular, so there may be this misconception that our crown jewelries, our main business is to write software. No, in software development, main business is to develop and engineer and maintain this software, and writing it is just one part of its expenses. And now about practitioners myth. I think that the most widely spread is due to emergence of social networks or software which I call non-critical software. Non-critical software is any social network you can imagine: LinkedIn, Twitter, Facebook, WhatsApp, Snapchat, TikTok, whatever. Why these are not business critical? Because users of these systems do not pay anything for developer and maintainer. You don't pay anything for Meta or Facebook, you do not pay anything for Google, you do not pay anything for Microsoft if you use just their online services, etc., etc. You are users, remember, but you are not customers. And so, therefore, Mark Zuckerberg introduced this idea for Facebook: move fast and break things. So, no need for all these procedures and approaches what we will talk about in this course, how to minimize error rate, how to ensure quality, etc. Just write code, put it in production. If something breaks, users immediately will tell you what is wrong and you will just fix it. And this works very well for these non-critical applications when users are not your customers. For me, typical example would be website odo.lv, and it is not critical for my business. When I was active in this business, I am not so active anymore, but when I was, this was not my important part of business. So if something went wrong there, not many people cared. What people cared was about specific customized solutions for specific customers, which I developed. And my website was just a public face for it, etc., etc. So remember, you can move fast and break things, and you may not follow procedures, you may not do testing, etc., etc., but this works very well only if your users are not your customers. If your users are your customers, they are paying your money for this. Sooner or later, if market is not skewed towards you because of corruptions and other things, you will be out of business. As simple as that. So remember that move fast and break things works only for non-critical software. Non-critical software may be also your pet projects which you develop in your free time, and only you and maybe 3-4 other users care about this, etc., etc. So it may work in some cases, but if you will try to apply this approach everywhere, you will get into big trouble. Other misconception not so widely spread around is that when you write your software, get it to work, your job is done. Of course not. Remember this previous misconception that it's also related with this idea that closed source commercial of the self product is product, and so when you ship your product you are done, but actually you are not in product creation business, you are in product support business, and because of that, getting your product done is only initial part of your activities and headaches, because you still need to maintain it, to get it working in changed environment, because software and hardware of your users change, software and hardware of developers change, etc., etc. So you will be successful only if you also will pay the same amount of information or even bigger amount of information about maintenance of your software. And then for practitioners also there may be some misconception about things that you don't need documentation, because documentation just slows you down, because code is self-documenting and everything else can be just learned out, etc. Again, this works pretty well for small-scale projects, what you can write alone, what you can write in short time in small teams, where software is not business critical, so customer business do not break apart when there is some issue in this used software, where complexity is so small that it actually can be self-learned by trial and error, etc., etc. So again, that works pretty well in small simple projects. For non-critical projects, will not work for large complicated projects, will work very well just to get you into trouble. And now about other involved parties called stakeholders. So stakeholder in general English means everybody who has a stake in it. And what are these different kind of things? Different kind of business managers coming from your customer, or representatives, higher representatives of customer, end users, or users in general. And remember that, again, customers and users may not be the same. In many software, these are absolutely different things. Particularly about Facebook, if we go back, you need to remember that if you are curious, you may check how Facebook move fast and break things for their real customer, which are mostly payers for their advertisements, because that they actual paying customers. And I will not be surprised at all that regarding to this business, how they provide support and services for their paying customers for their advertisements, they actually are not so relaxed about changes and breaks than they are about regular users, which do not pay for them anything. Then they are software engineers or developers. So engineer is a little bit wider generalization than just developer. Different kind of support personals like systems administrators and help desk persons and trainers who trains users for software, etc. And what is essence of software engineering in general? First, we need to understand what problem is, because without understanding what problem is, we will end up with wrong solution all the time. Hopefully, what problem is more or less understood in this area, and I say just hopefully, because maybe even here some big misconceptions plays there. Then you need to plan what solution is for this particular software, how to mitigate this problem, how to make it less expensive, less painful, etc. Then carry out this plan, follow these ideas, how to minimize your risks, your pain and effort, etc. And then you need to check what your result is. Did you actually achieve your goal successfully or not? And if not, what were differences and what went wrong? And to understand this problem, first we need to understand what are problems of all involved stakeholders, like from service provider perspective, from service user perspective, from customer perspective, etc. And one of the important thing is that in difference with hardware, software is built much more immature or unready than hardware. Again, it is chicken and egg problem. Software is easier to redesign, redevelop, and because of that, in most of cases, all these requirements, what is actually needed, are much less precise than for developing hardware and manufacturing hardware. And therefore, many things may be unknown, and biggest headache is not about known unknowns, because if you know that you don't know something, you are at least somehow prepared for it. But in many things, especially in large complicated software, there may be unknown unknowns, which are very big problem for inexperienced developers, inexperienced organizations when they try to come up into new business, because different kind of problems may come up which they actually didn't think about, and that's the biggest problem. And so idea here is somehow to try to make as much of unknowns known unknowns, and when these are known, then of course you can try to solve them somehow. And then, particularly for solutions, nothing is happening in empty space. There is always prior art everywhere. Even if you start to go into some very new business, you still may use the same approach to develop software, test software, deploy it, etc. So first is to see similarities between your needs and problems with some already known needs and problems. So you try to see patterns and similarities between different kind of projects. And project is in general activity with beginning and the end. And has somebody solved similar problem? If they solved it, how exactly solved? Is it applicable to your particular thing or not. So you try to learn from mistakes of yours or mistakes of others, or success of yours and success of others. And of course, you shouldn't be biased here, and remember about your success and failures. And about carrying out plan, important thing is that first you need to have one, and second you need to have abilities and approaches and tools to see progress. Because one of worst case scenarios is that your problems becomes very suddenly. And here, to be pessimist like me helps, because I never can understand persons, either politicians or just average persons, who say that something suddenly changed in single day. Like if you look on very global, recent things like something completely changed when Russia invaded Ukraine. No, there was pre-events before that. Many saw that coming, and only these who didn't track these less visible things, etc., then suddenly everything changed for them in one day. Similarly about all these things regarding to little bit older things like COVID-19 pandemics, that for some very social guys, very optimistic guys who never thought about bad outcomes and possibility, everything changed when all these lockdown requirements came into force. No, for me, person like me, almost nothing changed. Actually, if I think about this, I think that particularly for my mindset and lifestyle, COVID-19 was not a bad thing, particularly for me. Yeah, so if you can't see small things and put these together in some larger puzzle, then there may be possibilities when everything changes to worst in single moment, in single day, in single month, whatever. But it's not actually the case. If you analyze things before that more carefully, you will always see that there were warnings, there were issues which you just somehow ignored. And therefore, when you work according to some plan, it's always very important to understand how exactly you can track your progress, how you can see these early warnings, and what to do about them. If you will not, then may be that you understand that your project is completely failed only when deadline comes. And hopefully that will not be the case for anybody in this course about your practical activities, because we will try to teach you what are these early warning signs about your issues and problems where you need to work about, so you will know more or less timely what kind of problems you currently have and how to deal with them. And then final part is how to deal with results. And with results, of course, qualitative answer like yes, no, reach it, not reach it is good, but for any non-trivial problem, usually you want to get some scale between yes and no, like what is partial, gradual achievement, etc. And we will talk about this in more details about quality assurance, that if you can give some range of numbers in some kind of achievements, it is always good, because it minimizes risks of misunderstanding, misconception, miscatching things, etc. So you need to have tools how to understand how good or bad one particular achievement and then achievement in total is. And then some of slogans, short ideas, what you should apply for software engineering in practice, you always need to remember a reason why something exists. If you follow prominent engineers like Elon Musk, in one of his discussions with some journalist, he told about developing Tesla cars that they tried to solve problem with these cars, and then lately they find out that this detail actually shouldn't be in this car at all, because it was introduced just because of misunderstandings and assumptions, etc. Another is principle called KISS, keep it simple, stupid, maintain the vision. Vision always may be updated. What you produce, others will consume. Be open to the future. Plan ahead for use, and in general, just think. And so here, I think I covered it already, what computer science is and what software engineering. And then we will talk in more details later about different kind of models and how these models are developed. Models are developed from practical observations, and model is simple enough to understand, simple enough to illustrate, but good enough to describe something important in real life. What is very important is that real life in non-trivial cases is always complicated. And you can't deal with all possible complexities all the time, but you may pick up some very important aspects of all these complexities and deal only with these and still get good approximation, good result, even though you ignore many things. And that's what these software engineering models are about. They are simple enough to focus your attention and be easy enough to understand, but still relevant and good enough to describe real-life situations. And we will talk in more details about waterfall model of systems, engineering, V model, about Agile Manifesto, which also relates with this move fast, break things approach, that sometimes you don't need to have very rigid power structures and planning and tracing of executed plans, etc. So in different subsets of software this works pretty well. Then particularly for agile principles, DevOps principle is quite new thing, which also deals with many iterations, which tries to automate many things as possible to deliver software to production as fast as possible, because if you can do it fast, probably it is cheaper than if you do it slow. And then different kind of process flows coming from different approaches. And important thing here is that if you look on important differences are two. Either you go only forward, or you go into loops, or something in between. So waterfall model is going only forward, DevOps or Scrum is going in loops, and then there are some models where you do go forward in general, but some smaller parts do in loops as well. And then we will talk about other activities like how to specify software, how to develop it, how to validate it, which means that checks that software is what customer wants or user wants, and how it to evolve. And then we will look in more details about software engineering processes from different perspectives, from different ideologies. But most of these will come either from different kind of quality assurance or standardized processes. And so we talk about software process definition, life cycle, about improvements of software, measurements, and a little bit about tools. And then, not all processes are with the same importance. Of course, most important thing is to develop software, test it, deliver to the user or customer, and maintain it. These are primary processes, but they are hopefully concurrent, a parallel stream of activities which you can do called supporting things like configuration management, quality assurance, verification, validation, organizational things, what you can do inside your entire organization, not only in project like train new persons, do process measurement and analysis, do different kind of improvements in organization, and also through the cross project you can reuse approaches or software, etc. And here is one of model how to look on complexities of real life, standardized with International Engineering blah 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 Association, or IEEE or IEEE, and what is AI, I don't know. So all this software life cycle is composite streams of activities coming from so many different kind of activities. Or different way how to look on this ISO IEC. ISO is a very prominent organization to standardize hardware. Almost all standards regarding to electricity, regarding to bolts and nuts and screws and steel types, etc., are standardized by International Standards Organization. But they also have standards regarding to software and software development, and also for quality assurance of software development. So that was newer branch introduced for them when software become more important. So this is also different kind of model. How can you look on these things? And what is important about all these models is that neither of these are wrong or completely right. All of these models looks on real complexity of real life, and in this case not everything in life but just software engineering from different aspects, and of course they can pick out and pick up different items to look on more details because of their priorities. So hopefully they are somehow overlapping and complementary, even though initially for you it may look that they are actually contradicting each other. In general they are not contradicting each other, but they are just looking on from different perspectives on different aspects of these things. And that would be about introduction about this course, what we will look. Do you have any questions or comments about it so far? And in second shortest part for this day I will talk more about software engineering, not about terms so much, but about ideas and concerns. And first concern, of course, is software cost. Knowing that storing just bits or bytes or megabytes or gigabytes or terabytes is so cheap, development and engineering in general of software is very expensive, and it is somehow strange because bits should be cheap, but development of them and producing of them is quite expensive. And because of that, of course, software is quite different with hardware. So materials for software are cheap, but development process is expensive. For hardware, depending on how high-tech your hardware is, if it's low-tech, then all the costs are mostly just materials, which is nothing for software. But if it's more high-tech, then of course development and manufacturing is also quite labor-intensive, skills-intensive, and therefore expensive. And many ideas of software engineering and development in particular are about minimizing costs. Or if you can't minimize costs directly, then at least somehow indirectly influence this and minimize risks that these costs will go out of the roof, grow exponentially, etc. And if you look on different models, so this model is about linear approach like waterfall. You plan in advance, then you follow plan. Problem is that usually each of next steps or stages in software engineering is approximately 3-5 times more expensive than the previous step. And that means if you catch all bugs and misunderstandings and other things early, then fixing them is much cheaper. So this is one approach. If you do planning in advance, then carefully follow your plan and check how you are progressing during this plan. Then you do as much as possible to catch bugs earlier, because that saves you money. If you do different approach like iterative development, DevOps, or just Scrum, or whatever, it's a little bit different. For example, for waterfall model, usually these all next stages are more expensive than previous one, and then I will tell you, soon actual maintenance is the most expensive one. For iterative development, because they may need to redo more things during development happens to be the most expensive one. For a more complicated software, like you build some component, some part of larger system, like you have enterprise resource planning system, customer relationship system, or whatever, and you just build some module regarding to warehouse or finance or whatever, then the biggest and most expensive one is integration and testing to check how it works together. If you also include costs of maintenance, and of course it contradicts this old school approach. Not very old school, because before that also development of software was distributed freely. But for commercial off-the-shelf systems, this is not the case, but if you also maintain officially with maintenance support, then actually system development, which may be all these parts put together here, usually maintenance of system is most expensive part of the system. If it's 5 years, it may be 1/3 of total costs. If it's 7 or more years, it may be much less than tenths of all the costs. So that's one thing. And if you want to see patterns here, in general, the most expensive part of project is that part which is the most critical and most risky one. If you risk doing iterations, then that will be probably most expensive one. If you are in risky business of systems integration, then the most risky part and probably most expensive will be integration and testing. If you risk your business and provide software as is for cheap, and then try to get income from maintenance, then of course that might be risky part. That is the most expensive one. Another problem is that this is probably already seen to you. There are 3 aspects of quality software. We will go in details later, but idea here is that if you get something in terms of scope, that means you deliver what you were obligated. If you are in budget, in cost, and deliver it in time, that means you provided high quality service to your customer. And problem is that it is very tricky to balance and get every of these three aspects in the range. It's very easy to get done only two, very hard to get all three. And because of that, there is the slogan, good, fast, cheap, choose two. But if you need to choose all the three, then again it becomes much more complicated science and complicated areas than choosing just two of them. And so for most of projects I have not checked serious studies recently, but last time I checked that was several years ago. In general, if you consider cost, scope and time of software development or software engineering in general projects, approximately 70% of them failed to reach all the three of these aspects. Maybe now it is improved, maybe not. And why it happens? First, software becomes more and more complicated. And of course you do this divide and conquer approach, and you use more and more things taken as granted. So you put your addition of this overall large environment and the system on top of many existing things, but still, in general, software becomes more and more complicated. Some may say that exponentially, I don't know, but definitely it becomes more complicated, and dealing with complexity is hard. And so all these different kind of approaches somehow try to deal with these complexities, delegate basic tasks to somebody else, introduce precise borders which doesn't change with interface, etc. But still, all these approaches are just catching up, increasing complexity of the software. And because of that, in general, this failure rate, this success is not increasing for, I do not know, 20, 40, 60, 80 years, because all these approaches which are developed to deal with increasing complexity are not silver bullet. They may try to solve some parts, but still overall achievement is much worse than in other areas, like in hardware development, construction, etc. So, and then there are different kind of life cycles, and during these life cycles many things happen, and developers are mostly oriented only on development of software because that's when they are involved in systems engineering. But before and after that, and in general, there are many other things happening as pre and post activities, conditions, etc. And from engineering perspective, these are also important because as more and more software is developed, even as a closed source applications or open source applications, you try to get more and more software already developed, and you try to reuse this, build your own solution on top of existing one, and that means as more you rely on many other things, as a smaller part of your overall solution in the system engineering is development itself. I myself have mostly worked in different kind of systems integration projects, and as I jokingly told, usually all my code can fit in few kilobytes of text, and everything else is just putting together different kind of external libraries and make them work nicely together. So, particularly when I worked as a freelancer, most of these solutions were systems integration, and development was important but not the biggest part of these projects, and currently as well. And so therefore you need to pay attention also to related things about your software, because these are also very important, and actually they become more and more important. That's why you talk about platforms, you talk about cloud services, etc., where they try to provide you all this needed infrastructure as a already prepared solution for your particular needs. And so then there are different kind of these supportive activities, which is not about development, but about maintaining progress of your projects, monitoring different kind of criteria to check how this progress is going, etc. So we will talk in more details probably about project trackings and controls, technical reviews, quality assurance, definitely will be covered, configuration management, version control systems particularly, document preparation and production, that will be mostly your practical exercise, usability, measurement, risk management. And so there are different approaches, but they have some idea, a simplified model, which somehow shows all these complexities in much simpler form, and then they can prescribe you some kind of things what you need to do, like pills to take regularly to get your projects working more or less successfully. So there may be different kind of rules, recommendations and guidance, etc. Actually, if you look, for example, for ISO standards, they have very precise meaning about shall, must, and at least these. For example, what is mandatory and what is optionally. So similarly for this different kind of model, they say that according to their principles, these are mandatory things to do and these are nice things to do, which if you can afford, probably will minimize your risks and etc. Of course, sometimes risking you can get successful by risking. Similarly, as you are gambling in different kind of games, you may win or you may lose, but you never know. And never knowing, of course, is bad in organized business, and therefore instead of just poor luck and gambling, they try to minimize these risks and make it more predictable. And of course, making this more predictable in general, this means that your success may be more expensive than just gambling, but it is more predetermined, and that's a good thing. Yeah, and then there are different things. How can you look on software? There are different kind of set of projects. As I told you earlier, there are very different environments, how software lives and how it's used. Also, there may be very general products like Microsoft Office or LibreOffice are generic products. You may look on them as written for the shelf, and then everybody who wants to use them takes them off the shelf and either use for free as for open source software or pay money. And there may be customized products, so customized that only one single customer or user is using it. And of course, as much as you can cover everything with these generic products is better, because it is more predictable, sometimes less expensive if you use officially and legally like open source software than for customized products. And the general trend is following, that what was customized product some 10-20 years ago sooner or later becomes generic product in overall world. Like for example, 20 years ago you had to buy very expensive CAD software for systems engineering for real modeled systems for cars and buildings and ships, but today you can get like OpenCAD or FreeCAD for free. Probably they are not as good as CAD software, this original one, but they are good enough for different kind of most of users. So, and usually what is happening is these customized products, if they are successful at all, becomes generic products, and similarly for CRM software, ERP software, etc. And about software quality, what are important things, I will tell you probably later. About details like maintainability, how easy software is to maintain, and usually if you want to make software easier to maintain, you need to put more effort into development. Dependability and security, which is actually independence. Dependability is related to independence. And how efficient it is, how efficiently it uses resources, and how it can be accepted by users, etc. But also what is important is that to use software you need to have skills. And these skills may be inherited from your parents, from your environment. For example, basic skills just to log in some web-based system, add some data there, etc. are mostly known for digitally educated people. But as soon as you go into more specialized things, again, training is quite expensive thing, and therefore there is interaction between software and users. Users learn how to use software and influences how this software is developed forwards, because if users try not to use some particular feature of the software, this may be dead after some time and cut off from final product because nobody uses it. Then you don't want to waste your resources on developing features which nobody uses. So there is like symbiosis between users and software, and users influences how software actually develops. And because of that, also there are external pressure on software how this should work in different environments. For example, these times are long gone that you could create a website in which says that best used for Microsoft Internet Explorer 4. So they could proudly say that their website is developed only for Internet Explorer. So of course Google Chrome now is almost as prominent as Microsoft Internet Explorer 20 years ago, but not so dominant, because there are still Firefox and Opera and other things. And business and society changes how the software is used. Security and trust also influences, and also scale. Usually if you start like startup, you start small and then you need to scale it up. Sometimes you need to rewrite entire software because what was written in scripting language do not work for heavy load anymore. And so there are these different kind of systems, how they work, etc. And therefore to get out fundamental principles of all this diversity is quite hard. Hopefully these ideologies which I tell you are more or less general and can be applicable at least for some set of projects you will see by yourself and participate. But this is still work in progress. And yeah, as I told already, one of slow but important trends is that gradually and slowly software development goes away from principle introduced by Microsoft, then followed by Oracle and IBM, that they developed closed source software where you need to pay royalty just to use for it, and usually you don't even get any maintenance for that, to the free libre open source software which you can use without maintenance and technical support for free, and you can integrate and put it together in your own way. For example, I myself, for last, 20 years, I have not always developed a final product as open source software, but definitely what comes in is only open source software as a basic bricks for this solution. Now, when I'm working for Netcracker, also this trend is that we go away from, for example, Oracle relational database to open source database like Cassandra, which is not a relational database anymore, or MySQL, because in general it is cheaper to use open source software, even though final product is, at least for now, very carefully guarded closed source software, because currently company works in such ways that its ideas still need to be hidden behind this actual execution of the software. And so more and more software because of that is reused. So instead of building very basic things, everything by yourself, just using general programming language, you use frameworks, you use libraries, you use many things. For example, when I worked as a freelancer, all these web applications, which were very customized and specialized, were built on top of XWiki content management system. So probably the most widely used wiki system is MediaWiki, which Wikipedia runs, but XWiki was positioned as enterprise wiki system. Some of you maybe have heard of Atlassian Confluence. Atlassian Confluence is also content management system intended for large enterprises with different kind of integration possibilities, etc. And XWiki was built as a competitor, open source competitor for Atlassian Confluence. Now, of course, these two systems have, I think, diverged a little bit. But so idea here is that you can build pretty heavy and complicated web systems using content management. And of course, many customized web systems are built on top of Drupal or WordPress or whatever. Then we will talk a little bit about management and team forming, how teams are formed. Here, probably you will start with practical exercise, and then we somehow will try to put some theory behind it, because in this theoretical part, of course, project management is at the end. So that means that if you do not have previous experience and skills, your practical exercise will be poorly managed, but when you will finish this course, hopefully you will know how to manage teams better. And particularly for your teams, I think that for small-scale projects and your 12-person weeks project is definitely small, this iterative agile approaches works much better, especially if you don't know what your project is about, because then iterations are better than planning everything in advance, because if you don't know what will project be about, you can't make precise plans in advance. So then we will talk a little bit about management and leadership, etc. But then I want to say finally in this first session something about your work in general, and that's about software engineering and ethics. So problem is that software is used almost everywhere, which uses electricity and has some chip inside it, and that means that software has become so general tool like axe or knife, which can be used for something good and also can be used for something bad, unfortunately. Similarly to nuclear energy or whatever, with great power comes great responsibility. And as for more important and critical, not only for businesses but for entire society, software is used, of course, as more responsibility involved engineers need to take. And for example, I don't know how you followed this, but before previous elections, actually after previous elections when Trump got elected as President of the United States of America, it was proved that quite a lot of influence for voters' decision was made by Facebook, by different kind of fake articles and fake news and information in Facebook, because official policy at that time was that Facebook just provides a platform and do not manage what content different kind of users, including trolls, put inside it. But there was investigation after that, and that was one of these things that if you provide such powerful tool for society, then of course you should be responsible for that tool, that it is also abused or used for wrong things. And similarly at both electronical voting elections, and this is completely different topic about security and cryptography, etc. But in general, we as software engineers cannot provide electronical voting as secure and safe enough as paper voting with existing solutions. And everybody who thinks otherwise either don't know or has his hidden agenda, like Russia is currently talking about next elections could be made electronically. So either they do not know or they have hidden agenda about actually completely different ideas why software is used there. And I hope we will have time to touch these things. We already touched it, for example, how to deal with intellectual property rights. In general, if you are not unlucky, like mom of 3 children in USA who got sued for few millions of dollars for illegally stealing few movies somewhere in torrents or whatever, these are just showcases coming from copyrights industry. But in general, if you are a private person, nobody cares. If you are working for business, you do only legal things, and not only legal things, you do ethical things, you do things what you think are right for you, for your employer, and for society in general. So you need to follow. Intellectual property rights are stupid, they are out of date, but they are still legal. And there are many things which are stupid but either legal or illegal. So unfortunately we are not living in an ideal world where everything good is legal and everything bad for society is illegal. So there are some relations and correlations, but these are not completely aligned. About computer misuse, about confidentiality, this is mostly about your employer and how you use your competence. And there are organizations. One of organizations is in USA, Association for Computing Machinery, ACM, but it's also widely known. And the most widely known is Institute of Electrical and Electronics Engineers, IEEE or IEE. So initially this was about electrical things, etc., but it was also extended to software. So these are the most influential organizations in software development. Of course, regarding the quality standards, etc., another even more influential organization is ISO, International Standards Organization, and they have declared principles which all the software engineers should follow. Similarly to, kā to sauc hipotekārta zvēres in English, not same, but similarly as, Dr. O, similarly to Dr. O, because it becomes so influential and so important. And what are these ideas? That you can sign this by yourself as a private person, but the idea here is that actually everybody who got some engineer's degree and specialization, similarly to doctors, should make this out also about software development. That first, everything you do mostly to provide benefit for public interest, and by public I mean society, not like public sector. That's the most important one, and including that, of course, you provide the best of your work for your employer and client. Then for your product, you use your own best judgment, what is right and what is wrong. You manage everything in a such way that you develop it in the best possible way, that you rate high your profession and you are proud of it, and you try to be one of best of professionals in this profession. You rate high your colleagues and collaboration with them, and you try to improve yourself lifelong and always do your best. So idea here is that software engineering is very important, as much important as healthcare, and there should be something similar to this doctor's oath, that this should also will be given. And if you think that's nothing, then there have been studies about something else, that if people promise something, they of course care about this promise much more than if they didn't promise anything. Particularly for Accenture, they had some slogan sometimes, it's related to project management, under promise, over deliver. But anyway, you have to promise something. And so that's important aspect for you as becoming software engineers, becoming professionals to think about. And here, maybe you have heard this from your relatives, your parents. There is Latvian saying, mazliet zakt un mazliet melot nav nekāds grēks. So if you steal little bit and you, as a cheat, lie a little bit, it's not big sin, because nobody is ideal. You start with your small sins, like you say you will be in 5 minutes. Actually, you know that you probably will not make it in 5 minutes. You will be in 10 minutes or half an hour. And so here also, if you are desperate and you just need to earn money for some employer, you can do whatever you like. You can develop software for nuclear bombs and missile guidance systems. You can develop software for gambling, particularly for different kind of addictive games, where actually medics, professionals like psychologists are involved to make these games and social networks as well as addictive as possible. But you shouldn't be proud about this, and if you are in desperate situation and you just need to pay your bills, you do your job which you hate just to pay your bills, but otherwise your reach and goal of course should be in this direction, that you are involved in software of which you are a proud part of. And I also always try to do such thing, and I sometimes didn't accept some proposed projects related to like digital currency and bitcoins and gambling industry, because I think that this is not something to be proud of. Particularly in this area we can speculate and discuss. I worked some time in eGlobal, whatever it was called, but the short name was eGlobal, and we developed software. I actually was involved in automated testing for currency speculations. Yeah, and I didn't have projects for my freelance job, and I participated in it, but I was not very proud of it. But what was excuse and rationalization for them, and it's quite correct, it's similarly if you produce narcotics or alcohol or whatever, because people are weak, people are addicted to things, and if like company eGlobal would not provide, and again, currency speculation is gambling. You may rationalize it that some of these speculators can make money out of it, but it is just a public facade. I have worked in this business and I know it is just gambling where you use real money instead of like cards or these coins or whatever. And so idea here was following, that if eGlobal would not work in this area, this place would not be empty, because there are always people who are addicted to things, who want to do in this, and somebody will provide this service. But yeah, you can do this if you have to, but you shouldn't be proud about this, and therefore you should work in maybe not very exciting things like just beans counting, like finances, ERP, CRM, very important aspects of software. Not everything is exciting there. And so take this together with you as well. And so, finalizing, what are key points? First, software is eating the world. And software is almost everywhere. Now even spoons and closet, how it's called, toilet closets are with software. I think that's stupid. Not stupid for these spoons which are used for some disabled persons. And because of that, it is quite important. Not every software is as important as other. Remember that usually you have to be much more careful, much more ceremonial, and plan much more in advance for business critical software. And remember that in many cases your users are not your customers, so that means if you provide just some system for your users, but your customer is somebody else, like my website odo.lv or facebook.com, then of course you may be much more brave and risk much more, because you will not get penalized for that. But if you are working with medical system, with military systems and embedded systems like artificial satellites, etc., you need to be much more careful, and all these procedures must be much more controlled and precise, because then you may lose quite a lot if you are not lucky. And so because of that, either you are very greatly responsible for something like Facebook, now renamed to Meta, for presidential elections in USA a few years ago, or not so. And therefore you should always consider this public face of your profession, and try to do your best that this profession do not become badly popular. Of course, Goebbels has told that there is not bad publicity, there is only publicity, but I think for our profession, bad publicity probably will hurt. And that's it from me for today. We still have some time for questions and answers if you have any.